Hello friends, welcome back to another episode of Automation Digest. Today I have come with a DSA problem, which is asked by many organizations. It is a easy problem. The name of the problem is to sum. Let's go into the problem and we'll solve it together. The problem here talks about an array of integer being provided and an integer target being provided. We have to find the indices of two numbers which add up to the target. We will be assuming that there is exactly one solution and we should not use the same element twice. Now there are multiple variations of this question. Sometimes you may be asked about the indices, sometimes you may be asked about those two numbers. In either scenario, the approach remains the same. The examples that are provided over here are, if we have 2, 7, 11, 15 in the array, target as 9, it's visible that 2 and 7 add up to give us 9. Now this numbers indices are 0 and 1, hence the output. For the next one, the target is 6. The array is given as 3, 2, 4. So 4 and 2 add up to give us 6, which means my answer would be 1 and 2 because of the indices where 2 and 4 is present. Same for the third example with array as 3 and 3. Target as 6. 3 plus 3 is 6. Output is 0 and 1 because of the indices. The constraints are num's length or the array length cannot be more than 10 to the power 4 and number cannot be more than 10 to the power 9 or less than minus 10 to the power 9, which also means the number can be negative. Target can be anything in the range minus 10 to the power 9 to 10 to the power 9. If we look at the editor, the parameters which are passed are num's array and integer target. Output is an integer array, which will return us the indices of the numbers which add up to give us the target. So how do we solve it? Let's assume this example, which has an array 2, 3, 5, 4, minus 2, 0, 1, and the target as 9. The first approach can be creating all possible pairs of two numbers. While doing that, we will definitely come across the numbers which will add up to 9, which means we will first add 2 and 3. The sum is 5, not equal to 9. We move on to 2 and 5, again not equal to 9. 2 and 4, not equal to 9. Similarly, 3 and 5, 3 and 4, and so on. Unless we reach a point where we add 5 plus 4. This would result into 9 and hence we would come out of the loop. Now if you notice, it is a O of n square time complexity. We do not want to do it. So the optimized solution would be, we do not want to do it. We have to reduce the time complexity. How do we do that? From the example, we can understand that for any number, when we add that number to some other number, we have to arrive at our target, which means 2 plus x has to be equal to 9, which also means if there exists a number 7 in the array, we will find the indices of both 2 and 7 and that would be our output. And we continue to do this for all the other numbers. Now while we are doing this, we can store the values that we have already passed through in a map along with the indices, so that later whenever we come across the required number, we can directly provide the value. In our example, when we come across 4 plus 5 equal to 9, hence the output is 4 and 5's indices, which is 2 and 3. In this case, my time complexity will be O of n. So let's first do the solution in brute force and then let's proceed with the optimized solution and see the difference. So in the first approach, we will require two for loop to add all the numbers. Inside the first for loop, we will have another for loop which would go from the next number to nums.length. And inside this, we have to find a pair which adds up to give us the target. If we find such pair, we would return the indices of those two numbers in the pair. And if we do not find any such pair, we would return null. If I execute this code, this would execute properly. And also, if I submit it, the result would be all working, but the time complexity would be very poor of order O(n) square. Now, to make the time complexity better, what do we do? First thing, of course, is to comment that solution. In the new solution, we should store the numbers that we have traversed through and the indices of those numbers. This would be helpful to identify the x, which is required to tell us the complement of the number which adds up to give us the target. Now we need to traverse through the array. Let us first define our x. Our x is target minus the current number. If x is present in the map, we would return the indices of the value in the map and I. If we do not find the x in our map, we add the current value to the map so that it can come handy in our later search. And while putting the value into the map, the first key is of course the number and the second one is the index. If we do not find any such pair, we return null. If I execute this code, all test case pass, and if I submit it, it is getting executed in 1 millisecond, and earlier it was executing in 44 milliseconds. That's all for today. I hope you guys have enjoyed the video. I'll come back soon with few more DSA problems. Till then, stay tuned. Happy coding.